Imagine a material that can heal itself without human intervention. This power lies within the wings of the cicada, a tiny insect that has been perfecting self-repair for millions of years. These wings are not just beautiful, they are a marvel of natural engineering. Scientists have discovered that they can repair themselves when damaged, a process that is completely automatic and incredibly efficient. This discovery is changing the way we think about materials science. Researchers are now looking to nature for inspiration, using these microscopic patterns to create new materials for use in technology and medicine. The cicada's wings are made of a material called chitin, which is both strong and flexible. This unique combination allows the wings to withstand damage and repair themselves over time. This natural self-repairing ability could one day lead to the development of materials that can heal themselves in everything from spacecraft to medical implants. When a cicada's wing is damaged, the microscopic structures on its surface automatically shift and interlock to fill the gap. This process is so fast that it happens in just seconds. These interlocking structures act like a puzzle, fitting together perfectly to restore the wing's integrity. Unlike human-made materials, which often fail after damage, the cicada's wings return to their original state. The repair process is not only quick, but also very energy efficient. The cicada doesn't need to use any extra energy or resources to heal its wings, which is a remarkable trait for such a small creature. This self-repairing ability is so effective that it can even protect the cicada from predators. If a bird tries to grab the cicada, the wings can quickly repair any damage caused by the attack. Scientists are now working to replicate this process in synthetic materials. If successful, we could see self-repairing materials in everything from clothing to electronics. The cicada's wings are made of a special type of chitin that is layered in a way that allows the material to flex and move. This flexibility is key to the wing's ability to repair itself. These layers are not just random, they are arranged in a precise, repeating pattern. This pattern is what allows the wing's structures to interlock and repair themselves without any outside help. When the wing is damaged, the microscopic ridges on the surface move in a way that fills the gap. This movement is guided by the unique structure of the material itself, not by any external force. The material's ability to repair itself is not just about the structure, it's also about the chemical composition of chitin. This protein is both strong and lightweight, making it perfect for the cicada's needs. Understanding how chitin works could lead to new materials that are not only self-repairing, but also incredibly durable and lightweight. This could have huge implications for a variety of industries. The discovery of self-repairing materials in cicadas has already inspired a new field of research called biomimicry. This field looks to nature for solutions to human-made problems. Biomimicry has led to the development of materials that can self-repair, resist damage, and even change color in response to their environment. These materials are being tested for use in everything from buildings to medical devices. One of the most exciting applications of this discovery is in the medical field. Scientists are exploring the possibility of using self-repairing materials in implants and prosthetics that can last longer and require fewer repairs. In the aerospace industry, self-repairing materials could be used to build spacecraft that can withstand the harsh conditions of space. This would reduce the need for maintenance and improve safety. These materials could also be used in everyday products, such as smartphones and cars, to make them more durable and longer lasting. This could reduce waste and save consumers money in the long run. The cicada's self-repairing wings are a powerful reminder that nature has already solved many of the problems we are trying to tackle in materials science. By studying these natural solutions, we can create smarter and more sustainable materials. This discovery could lead to a future where materials are not only stronger and more durable, but also more environmentally friendly. We could move away from single-use plastics and toward materials that last longer and can be repaired. As we learn more about how cicadas repair their wings, we may uncover new properties of chitin that we can use to create materials with even more advanced capabilities, such as self-cleaning or adaptive color-changing surfaces. This research is not just about materials, it's about rethinking how we approach design and engineering. By learning from nature, we can create better solutions that are more efficient, more sustainable, and more resilient. The cicada's wings may be tiny, but their impact on the future of science and technology could be enormous. This is just the beginning of a new era in materials science, driven by the wisdom of nature. Nature has always been a source of inspiration for human innovation. From the wings of a cicada to the structure of a spider's web, the natural world is full of solutions to our most pressing challenges. The cicada's self-repairing wings are a prime example of how studying nature can lead to groundbreaking discoveries. This tiny insect has taught us a lot about resilience, adaptability, and efficiency. By looking more closely at the world around us, we can find answers to the problems we face. The cicada's wings remind us that sometimes the best solutions come from the smallest of places. This discovery is just one of many that show how nature can guide us toward a more sustainable and innovative future. As we continue to explore the natural world, we may uncover even more secrets that can change the way we live and work.